Another powerful tool that we can use is this idea or this tool called slope-intercept, or the slope-intercept form of a line. How do we get that? Where does it come from? What does it look like? Let's imagine I have some equation, y equals 2x plus 4. This means that y and x relate to each other with some other constants involved in there. So what does this graph look like? Well, let's begin and find out its x and y intercepts since we've learned how to do that. So one is if we set y equal to 0, and solve for x, x equals a -2. So I have the x-intercept of -2 and 0. Likewise, to find its y-intercept, let's set x equal to 0. Y equals 4. That was kind of easy. Now we found 2 points. We can determine what that graph looks like based on that. Backwards 2 and up 0, over 0 and up 4. And there's what the graph looks like. But we can also take what we learned about slope. And what's the slope of this line? Well, if I have 2 points, and I'll set this one as my x1, y1, this is my x2, y2. I know the slope equals y2 minus y1, which is 4 minus 0. And my x2, which is a 0 minus a minus 2. And that equals 4 over 2, which equals a 2. So there's a couple of observations that I want you to notice in this. Notice this slope, and notice what my y-intercept is, or right here. Do you recognize those or see those numbers anywhere else in this equation? The slope, 2, is the same thing as this number right there, and this 4 is the same number right there. Now some people can say, oh, that's just coincidence. You know, the same thing that 2 plus 2 equals 4 and 2 times 2 equals 4. So therefore, if 3 plus 3 equals 6, 3 times 3 equals 6. That's not true because this is a coincidence. That pattern doesn't hold for all numbers. However, this pattern does hold for all numbers because we've tested a lot of them and we keep seeing the same pattern over and over and over again. So what we have here is we have a wonderful idea or a model called slope-intercept form. And the slope-intercept form follows this. That sum y equals mx plus b, where m and b are particular values on a particular line, and x and y's represent all the various different x and y's on that particular line. So this is what we call slope-intercept form of the line. And if we can turn any line into this form, the coefficient that precedes the x, that's our slope, and this value of b, we call that our starting point, or y, or where it crosses the y-axis at, or y-intercept. And if we can determine both of those, we have another way that we can graph lines. Let's look at a couple of equations here to see if we identify what its slope and its y-intercept are. So one line that I'm looking at is y equals 2x minus 4. Can you determine what its slope is and what its y-intercept is? Well, its slope is the value that precedes the x. If it's written in this form, the value is a 2 for slope, and the y-intercept is this value of -4. Now, it can't be just the 4 because it has to be written in that form. And to write it in that form, that it becomes a 2x plus a -4. And now you can see why the y-intercept is -4. All right? Feel fairly straightforward? Let's look at another one here. Let's say y equals 1/2 x plus 3 plus 2. Its slope Well, in this case, the slope is a fractional value. It's still the value in front of the x. It just happens to be a 1/2. And its y-intercept is this value of a 2. And let's look at 5x plus y equals 4. What is its slope and what is its y-intercept? Well, I got the value of 5 right in the middle, but it doesn't look like, it looks like it's in standard form, but not slope-intercept form. So what we need to do is, let's get it into slope-intercept form. So let's subtract 5x from both sides. The slope isn't a 5. The slope really is a -5. And its y-intercept is a 4. So to find its slope and its y-intercept, we always need to use our algebra skills to translate or transform the equation into slope-intercept form.